Ford is hitting the accelerator on electric vehicle production, built right here in the US by US workers, and not importing it. Ford just unveiled something that could reshape the automotive landscape as we know it. We've just seen a big change in customers. It's going to be as exciting as an electric vehicle. It's just a little different than what we thought it was going to be a couple of years ago. Their latest engine technology is not just an incremental improvement, it's a fundamental rethinking of how internal combustion engines can coexist with our electric future, delivering those ideas in a way that millions can access them. But I know Ford is the company that can and will pull this off. While most manufacturers are racing toward full electrification, Ford has taken a different approach, one that acknowledges the reality that millions of drivers aren't quite ready to abandon traditional engines entirely. At the heart of this innovation lies what is being called power density optimization. Traditional engines have always faced a trade-off between size, weight, and performance. If you want more power, you typically need a bigger engine. The engineers have essentially broken that rule. Their new 3-cylinder turbocharged units deliver power outputs previously reserved for much larger 6-cylinder engines, all while weighing significantly less and occupying a fraction of the space. The secret is not just one breakthrough, but rather a combination of advanced materials and manufacturing techniques. The company has incorporated aluminum alloy blocks with high-pressure die casting, a process that allows for thinner walls without sacrificing structural integrity. The result is an engine that is roughly 15% lighter than comparable units from just 5 years ago, and weight matters more than most people realize. Every pound shed from an engine translates directly into better fuel economy and improved handling dynamics. But the real magic happens inside the combustion chamber. A new coating technology for cylinder walls has been developed that reduces friction to levels previously thought impossible for mass production engines. This nanoceramic coating, applied through a plasma spray process, creates a surface so smooth that it allows the pistons to move with less resistance than traditional cylinder linings. The friction reduction might sound minor, at around 8%, but in real-world driving conditions this translates to meaningful fuel savings and reduced wear over the engine's lifetime. Turbocharging is not new, but this latest implementation certainly is. The latest generation of turbochargers uses electrically assisted compressors that, honestly, eliminate virtually all turbo lag. Anyone who has driven a turbocharged car knows that brief hesitation when you press the accelerator, that moment where you're just waiting for the turbo to spool up. Well, the electric assist spins the compressor immediately, providing boost pressure from idle. It's a hybrid approach without actually being a hybrid vehicle, using small amounts of electrical energy to dramatically improve the driving experience. The air flowing into these engines passes through a redesigned intake manifold system that is claimed to improve volumetric efficiency by nearly 12%. Essentially, the engine is breathing better, pulling in more air with each intake stroke. More air means more complete combustion, which means more power and cleaner emissions. The manifold design incorporates variable geometry that adjusts based on engine speed and load, optimizing airflow across the entire rev range, rather than just at peak power. The latest direct injection technology has also been integrated, capable of multiple injection events per combustion cycle. During a single piston stroke, fuel might be injected 3 or even 4 separate times, each spray timed precisely to optimize combustion efficiency. This level of control allows the engine to run leaner when cruising, using less fuel while still delivering maximum power when you need it. The injectors themselves operate at pressures exceeding 350 bars, atomizing fuel into a mist so fine that combustion becomes remarkably complete and clean. Here is where things get interesting. These engines are not being developed in isolation from the electric vehicle program. Instead, the company is creating what they call electrified combustion systems. These engines are designed from the ground up to work seamlessly with mild hybrid systems, incorporating 48-volt electrical architectures that can recover energy during braking and provide electric boost when accelerating. The mild hybrid system does something clever with what would otherwise be wasted energy. Traditional engines lose enormous amounts of heat through the exhaust and cooling systems. The new setup includes a thermoelectric generator mounted in the exhaust stream that converts some of that waste heat directly into electricity. So, these engines actually show up across the lineup, from compact cars all the way to mid-size SUVs, which, provides a pretty consistent experience and allows for economies of scale and production. Pricing is, well, competitive. Another crucial factor is that these advanced engines don't carry significant premiums over conventional power plants, making them accessible to mainstream buyers. Much of the development costs have been absorbed through manufacturing efficiencies and shared components across multiple models. For consumers, this basically means getting cutting-edge technology without breaking the bank, which is a really compelling value proposition in today's market. The engines also serve as a bridge technology. Customers who might be curious about electrification but not quite ready for a full EV can experience some of the benefits, like silent operation in electric mode and instant torque from the hybrid assist, while still retaining the familiarity and convenience of a traditional vehicle. It's honestly a smart strategy for gradually shifting consumer preferences rather than forcing an abrupt transition. The company is not alone in this pursuit. Other manufacturers have invested heavily in their own advanced small displacement engines, focusing more on cylinder deactivation technology that shuts down cylinders when they're not needed. Another has developed what they call multi-air technology, which precisely controls valve timing without traditional camshafts. Others continue refining their naturally aspirated Atkinson cycle engines that power their hybrid lineup. European manufacturers have long championed small turbocharged engines, but they're facing challenges meeting increasingly strict emission standards. The clean sheet design approach, starting fresh rather than evolving existing architectures, has provided advantages in meeting regulations without resorting to overly complex exhaust treatment systems. Japanese manufacturers are pursuing interesting alternatives, with one using compression ignition like a diesel but running on gasoline, and another developing a unique variable cylinder management system. The competition is fierce, and each manufacturer believes their approach offers distinct advantages for consumers. This technological diversity means more choices and, honestly, rapid innovation across the industry. Looking ahead, the lessons learned from this intensive development program are, honestly, just invaluable. The relentless pursuit of marginal gains in combustion efficiency, the integration of smart software for real-time optimization, and the use of lightweight durable materials are all disciplines that directly benefit the broader electrified future. The company is building a versatile technological toolkit. Whether the energy comes from gasoline, electricity, or future fuels, the core principles of maximizing efficiency, minimizing waste, and delivering reliable power remain constant. This positions the company not as one clinging to the past, but as one rigorously preparing for a diverse and complex automotive future. The engine development roadmap extends well into the 2030s, even as billions are, at the same time, being invested in electric vehicle technology. The company recognizes that different markets and different customers have varying needs. While urban drivers in developed countries might embrace EVs, rural customers and those in regions with limited charging infrastructure still need efficient, reliable internal combustion options. Future iterations of these engines will likely incorporate even more electrification. Research is ongoing into 48-volt systems capable of providing meaningful electric-only range, blurring the line between mild hybrids and plug-in hybrids. There is also exploration into sustainable fuels, ensuring these engines can run on synthetic gasoline produced from renewable sources, potentially achieving carbon neutrality without abandoning the combustion engine entirely. The manufacturing techniques developed for these engines are already influencing electric motor production. Precision casting methods, advanced materials, and quality control processes transfer across product lines. In many ways, the discipline required to extract maximum efficiency from combustion engines makes engineers better prepared to optimize electric powertrains. It's been demonstrated that the internal combustion engine is not a relic destined for museums, but a technology still capable of meaningful evolution. These new engines deliver power, efficiency, and environmental performance that would have seemed impossible just a few years ago, proving that innovation does not always mean abandoning what works, but sometimes, making it even better.